Hello students, welcome into our second lesson. In our first lesson, we learned about streamline and turbulent flow. In this lesson, we are going to learn the following. 1. Definition of terms used in fluid flow. 2. We will derive equation of continuity, which is basically an equation which describes relationship between pressure, velocity and elevation of a moving fluid. 3. We are going to do some numerical problems or some examples on how we are supposed to apply the equation of continuity to solve problems in fluid flow. Let us begin. So welcome. In deriving this equation, we made the following assumptions. 1. That the moving fluid is in streamline flow. 2. We assume that the fluid is incompressible. All that means that the flow does not affect density of the fluid. 3. We also assume that the fluid is non-viscous, i.e. it does not stick on the sides of the tube, and therefore it means that the viscosity of this fluid is 0. Let us begin also by looking at the definition of terms. And the first term is volume flux. And what is volume flux? This is the volume of a fluid passing through a given section of a tube of flow per unit time. And it is also called the flow rate. So this is what we are saying, that the volume flux is now the volume of the fluid passing through, let's say, this section of this tube at a particular time or per unit time. And in this lesson, we are going to say that per unit time is 1 second. And let the velocity of the fluid through region Y be Vy. Velocity on this region be Vy, and cross-section area be Ay. Also, let distance covered by the fluid per unit time be D. Then volume flux through region Y will be, volume flux will be given by the cross-section area. Of course, this is the cross-section area here, this one here, and it is of the shape of a circle. It is circular cross-section area. Then multiplied by the distance, and the distance in this case is from here to here. We are talking about region Y. Then it means that we will have Ay, which is this cross-section area, this one here. Then multiplied by the distance from here to here. But we know velocity Vy is given by displacement divided by the time. And displacement is already dy and time is t. Since flow is per unit time, it means that the time is 1 second. So that means that this t is 1, and therefore it means that Vy is equals dy. Thus, volume flux will be given by Ay Vy, and this one is very, very important. The SI unit of volume flux is given by cubic meters per second. Next, we have the mass flux. And what is mass flux? The mass flux refers to the mass of the fluid that flows in a given section per unit time. From this equation, whereby we have density is given by mass over volume, it means that mass will be given by density times volume. That you will get that by cross multiplying. If I multiply through by volume, if I multiply through by volume, this is what I will get. volume flux is equal to density times volume flux. So it means that you have density, which is represented by the symbol law, this one, times now by the volume flux, which we saw it is this one. Therefore, it means the SI unit of mass flux is kg per second. Since the fluid is not compressible, mass of the fluid leaving region Y will be equal to the mass of the fluid entering region Z. Therefore, it means that mass flux at Y is equal to mass flux at Z. Then we'll have this equation. We'll equate the two here. And as you can be able to see, the density is constant because it is of the same liquid or the gas. And therefore, it means that the density will cancel out because it is constant. And therefore, we will remain with this equation now. And this equation is what we call the equation of continuity. This equation is very, very important because it will help us to understand the relationship between the pressure, velocity, and elevation, or the height of a moving fluid. So we are where we wanted to be. It therefore means that the flow rate is constant, i.e. AV, which is cross-section area times velocity, is constant. So this is now the equation of continuity. Note, the velocity of the fluid is inversely proportional to the speed of the fluid. That means the speed of the fluid increases when the fluid flows from large cross-section area to small cross-section area, and vice versa. So it means that velocity of this fluid on this section, the narrow section, is higher as compared to the velocity of this fluid on this side, that is the V1. Let us do some numerical examples so that we understand how do we use this equation. The first example, water flows through a horizontal pipe at the rate of 3.00 cubic meters per minute. Determine the velocity of water at a point where the diameter of the pipe is 4.00 centimeters. The solution will be, as we have seen, flow rate is given by cross-section area times velocity. So the flow rate, so whatever we are given is the flow rate, this one. But it is also important to know that it is given in terms of minute, and we learned that it should be in seconds. So that is why we are dividing through by 60 seconds, because 1 minute is equivalent to 60 seconds. Then also, what can make you fail this question is not considering the diameter. We are given the diameter, but we are supposed to use the radius. So that is why you're supposed to divide this by 2 so that you get the radius. And then you are supposed to divide by 100 so that you convert the centimeters to be in meters. And then you multiply by the velocity now. Because we know that area is given by pi r, then you square. So it means that if you divide this side, you will get this value here. And if you multiply this side also, you're supposed to get this value. And that means if you make V the subject of the formula, it means that we will have 0.05 divided by the whole of this value here. That means that our velocity will be 39.79 meters per second. Example 2. Water flows through a horizontal pipe of varying cross-section area as shown in figure below. The velocity of water in pipe X is 4 meters per second. Determine the velocity of water in pipe Y. As you can be able to see, this pipe has varied cross-section area. This cross-section area is not the same as this one. The solution. Using the equation of continuity, mass flux is constant. That means if you take cross-section area of this region here, multiply by the velocity on this region, you will get the cross-section area on this side times, it is the same as the cross-section area on this side times velocity on also this side. So if you take now this is now the cross-section area on this side X, and it is also important to know that you are supposed to convert the square centimeters into square meters, and you are supposed to multiply with this value here. And if it is also possible, you can also divide this 50 by 10,000. Then you multiply by the velocity, and the velocity is given, which is 4 meters per second. Then it means that you're supposed to get also mass flux on the other side. So we have this, which is this one. You also supposed to change this one into square meters, then multiply by the velocity on this region, which is Vy. So we want now Vy, so we divide through by this value here, and then it means that when do that calculations here, you can use your calculator, you will get that velocity in this region is 10 meters per second. So as you can be able to see, the velocity here on this side is higher as compared to velocity on this side. And our final example, which is example number 3, in the figure below, the tube is filled with a liquid. The piston moves from A to B in 2 seconds. So we have this. It is a silage, and I want us to do these calculations here. The questions are: calculate the volume of the liquid in part AB, so we mean this part here. 2, the velocity of the liquid between A and B, this side. C, we have the velocity of the liquid through BC. So let us begin. The first question, A, the volume of the liquid in part AB, and we know that velocity, we have volume is given by cross-section area times length. Are we given the cross-section area? Yes, which is this. So it means that we take now the cross-section area, and you are supposed also to convert, and you will multiply with this figure here. Multiply by the length. The length also you are supposed to convert into meters, which you will multiply with this value here, will be equal to this. So when you multiply this one and this, you will get this. So it means that the volume of this silage from here to here is this value. Part B, what is the velocity of the liquid between A and B? Between A and B, The solution is this one. We know that the flow rate is equal to volume all over time. And volume, how do you get volume? Is cross-section area times velocity. So we will have this. Already we know the volume here, which is this. You divided by, you are given the time, and therefore it means that you will divide by 2 here, so that you get flow rate, or what we are calling the volume flux, so that you will be able to use cross-section area, which is already given here. So you convert times by the velocity, which of course the one we are looking for. So it means if you divide through by this value, the cross-section area here, you will be left with the velocity, the one we are looking for. So it means that you take this one, this value here, you divide through by this value. So it means that it will cancel on this side, and then it will move, or it will be divided onto this side here, which is this. And then that means that the velocity will be 0.05 meters per second. Then, what is the velocity of liquid between BC? Using the equation of continuity, A1 V1 is equals A2 V2. So that means that the mass flux is constant, it's not changing. So it means that the mass flux on this side will be the cross-section area here multiplied by the velocity on this region. Of course, we have calculated, and it is this value, will be equal to A2, which is this one. You convert cubic millimeters into, not cubic, sorry, but square millimeters into square meters, so that we'll have this value. So if I divide through by this value here on both sides, this is what I am going to get. I'm going to get this thing here. That means that velocity V2 will be equal to this 5 meters per second. And as you can see, the velocity also here on this region, which is narrow as compared to this, is also bigger as compared to the velocity on this section. So hope you have understood, and I have some good questions for you. These questions will help you to even understand more the equation of continuity. You need to do a lot of practice. You need to do a lot of assignment so that you understand even more. Because as we said in the introduction, is practice makes perfect. Perfection comes after much practice. So the assignment is here for you. We have some very good questions here, and some of these questions, the answers are found in our notes. You will find them there. But in case you feel there are some difficulties, it is always good to consult. You can consult your friend, you can consult your teacher, and also we as Scholarnet, you can also consult us. We are ready to help you, the learner. So these questions are very nice. So try them and try to see how far can you go. How far have you understood this lesson? And until next lesson, which is lesson 3, thank you for listening.